So, you think you can chain rule? We'll know in a minute. This thing involves a couple layers of chain rule. Let's see if we can get this thing figured out. I'm just going to rewrite it first because the power notation for trig functions is kind of lousy, and getting that out of the way will help us a bit. 4 is our leading coefficient. After that, what this thing means is the sine of x squared plus 2, and what haven't I written yet? This power, the square, actually sits like that. That's what this thing means. It means take x, square it, add 2 to it, take the sine of whatever that is, square the result, and then quadruple it. That's the order that this thing happens, and so we have quite a few layers to differentiate here, and that means the chain rule is going to go off more than once. When we do our derivative, well, the 4 just sits there. We know that derivatives go right through the 4 and just hit the thing that comes after it. At the outermost level, this thing is a square. It's the square of some stuff. And so its derivative is going to be 2 times that stuff. Don't change anything, just copy it. And then drop the power by 1. Okay, so the first step is just the power rule. Just as if you had x squared, you'd write 2 times x to the 1. Here we do 2 times sine blah 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 to the 1. Now, the chain rule says that blah 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 stuff, the sign inside, do its derivative next. So now we are, one moment while I blip this. Now we have taken care of the square, and we're just supposed to do the derivative of what's inside it, meaning the sine x squared plus 2. Well, that's a sine, so its derivative is cosine x squared plus 2. That's the end of the sine derivative. And now the chain rule says, wait, what was in that sine? Do its derivative now. And its derivative is, for the derivative of x squared, we get 2x. The derivative of 2 is just 0, so we can ignore that bit. And that is the complete derivative. So it had a layer because of the square, then a layer because of the sine, and then another layer because of x squared plus 2. And all of those pieces are multiplied together, and their product is our overall derivative. So if you're a slovenly mathematician, you could stop right here, but let's see if we can pretty this up a little bit. For coefficients, or out front terms, we have a 4, and we have a 2, that's 8. And we have a 2x, so that means we have 16x that we can park out front. After that, we have sine x squared plus 2. To the first power, we no need to write that. And then we have cosine x squared plus 2. And I think that's a good place to stop. There is a trig identity we could use to compact this down, but I don't think it's worth it. And I suspect they do it in the, okay, fine, I'll show you. This is a perfectly good place to stop, but in the solution in the book, just in case you're wondering, there is a trig identity called the double angle formula, or the double angle identity, which says this. It says that if you have 2 cosine something, actually I'll put it in the same order that we have here. It says if you have 2 sine something, cosine of the same something, that is equivalent to the sine of 2 times the something. So you have to have a sine and a cosine which contain exactly the same argument, which these guys do. You also need a factor of 2 out front. If you do, then you can compact that down and get the sine of an angle twice as big. So for example, if you did something with numbers, you could say if you had 2 sine 30 cosine 30, that ends up being the same as sine 60. Try this out, it really does work. So in this case, if we want to apply that identity, I'll leave it up. Here's what you would do. We need to pull a 2 out of here, so we're going to end up with 8x times 2 sine x squared plus 2 cosine x squared plus 2. I pulled the 2 out because there's 1 in the formula. For this thing to work, we have to have 2 times sine of something times cosine of something. And once we have that, we can take this entire piece, and here's our next line. The 8x just sits there, it doesn't change at all. And the formula says where you have 2 times sine of something times cosine of something, you can replace that with the sine of 2 times something, which in this case would be 2x squared plus 4. Is that better? I'm not sure. Maybe a little. It's shorter. I suppose that's something. So, okay place to stop, and optional tweak. Take either one you like.